A warm welcome to Conceptual Maths. Hi, I am Shreya, and today we are going to start the first chapter of class 10, that is real numbers. In this tutorial today, we are going to discuss the broad classification of numbers. Number 2 is one of the theorem in this chapter and two examples. So let's begin. In a broad classification of numbers which we have studied last year, we have something like this in a flowchart, where numbers can be divided broadly into two parts, imaginary numbers and real numbers. Now in imaginary numbers, all the complex numbers that come under numbers are imaginary numbers. About this imaginary number, we are going to discuss it when we go to class 11. Now, in real number again we have two classification, rational and irrational. In irrational numbers are all the numbers that comes under root and also which cannot be expressed in p by q form. In decimal expansion, irrational numbers are the numbers which are non-terminating and non-repeating numbers. Rational numbers are all the numbers which can be expressed in p by q form, and in decimal expansion they can be terminating or they can be non-terminating recurring form. These two definition of irrational and rational number we have come across when we were in class 9. Again, rational numbers are further divided into non-integers, integers. Integers are again divided into negative number, whole number, and whole numbers are divided into zero and natural number. So this is the broad classification of numbers. Now, one of the theorem in this chapter is Euclid's division lemma. Euclid's division lemma is the most important theorem in this chapter. The statement of Euclid's division lemma is like this. Given positive integer a and b, so a and b are the two positive integers. There exists a unique integer q and r such that the numbers a and b can be expressed in a is equals to bq plus r. Now this expression have one condition. The condition is r should be, or we can express r as 0 less r less than equal to r less than b. So our remainder, that is our r, should be equals to 0 or less than or greater than 0, but it should be less than b. So this is Euclid's division lemma. This is also can be remembered as expression that we used to do when we were in lower classes. So this is our Euclid's division lemma. Now in Euclid's division lemma, we can use this to find the HCF of two numbers. HCF of any two positive integers. Now how can we find these two numbers? So there will be a series of steps. Usually it contains of these three steps. The first step is, suppose the numbers are c and d. Here we have taken the numbers as c and d. We have to express this number c and d as c is equals to dq plus r. Q is the quotient and r is the remainder. The restriction for r remains, that is 0 less equals to r less than b. So this condition is always there for Euclid's division lemma. Whenever we apply it, this condition is always there. Now whenever we get r equals to 0, then we get our HCF. The HCF will be d of that number. That means the number which is the smaller one will be our HCF of the numbers. So if r equals to 0. Whenever r is equals to 0, then only we can find the HCF. The HCF would be the smaller number among the two. If r is not equals to 0, then the process will continue. The process will go on. The next stage, next stage of the process will be with d and r. Sorry, here I have made a mistake. It will not be b, it will be d, since the numbers are c and d. So if r not equals to 0, then we will use Euclid division lemma with d and r. That means the smallest number from the given numbers and the remainder. So after this we will find a new remainder. If that remainder, suppose the new remainder is r prime, if that remainder is equals to 0, then the smallest among these two will be our HCF. If that number is not equals to 0, again the process will continue considering the smallest of these two number, and suppose the smallest is r, then r and r prime or r dash will be our next batch of number that with which we will use Euclid's division lemma. So this is how we are going to find HCF from two positive integers using Euclid's division lemma. Thank you to be there and listening to the whole tutorial. I hope that I have cleared your doubts. If you are new to my channel and you like my content, then please subscribe to my channel. And if you like my video, then please do share this video with all the helpful ones, so that all of the youth get education through this tutorial. Thank you.